from Texas Instruments, and I chair the Debug work group and within the MIPI Alliance, and I guess I'm going into my 4th year of that chairmanship. And I'm here to tell you a little bit about what we do in Debug and the status of that currently. But before I go into any detail here, I want to mention that Marcia has also asked me to give a more detailed presentation tomorrow, and I think that can fill in a lot of holes that you'll see in this presentation, because we'll have to go relatively quickly. Debug is a very complex thing, as you all know, and MIPI debug reflects that complexity because we've created specifications at multiple levels within the MIPI space. And so I'll go through quickly the status of that now, but if anybody's interested in drilling down into this a little bit more, we're going to have a 45-minute presentation tomorrow where I think that more information can be seen by everybody. So, in general, as I have here, this mission in the sentence, we define interfaces and protocols for standardizing debug on mobile systems. And you can see by this list here, it's a vast variety of things, from board connectors to pin remappings to use other functional interfaces, system trace, the parallel trace interfaces, things we're calling gigabit trace and sneak peek, which are debug over high-speed networks. So we cover a lot of different things within debug. And as a result, we've actually had a lot of work product. So when we started years ago, we were looking to minimize the pin footprint, and as part of that effort, we ended up spinning off the 1149.7 standard into the IEEE as an IEEE standard. Some of the other efforts, we had the System Trace Protocol Specification 1.0, which is a very generic system trace set of primitives that we've defined a protocol for. We formalized the parallel trace timing interfaces within MIPI. We have a connector document. We've worked on an open system trace protocol specification, which is for software-based trace. It's the software infrastructure for that. We've updated the system trace protocol to a 2.0 level, adding some capabilities and enhancing the time stamping. We have a trace wrapper protocol specification that shows you how to merge multiple trace streams within a device in a standardized way. These highlighted things are some of the recent activity we've had. Last year, the second version of the parallel trace interface, PTI 2.0, was adopted. We had an update to the connector recommendation, version 1.1. And our current status is that we're working to, because you see we have all this stuff, one of the big things that we're trying to work on is a test and debug architecture overview document. This is a white paper type document that kind of pools all these different things together. And you'll see in the presentation tomorrow, I kind of introduce what that is and where debug fits in all through the system on a chip. So we're working on that. We have a specification called the Neural Interface for Debug and Trace, which will be released this year, well, to the board for consideration for adoption. And then we're working, since the last update, we have 2 new efforts. One of them called the Sneak Peek Protocol, which defines a command set for network access to memory map debug functions and architectures, and our gigabit trace effort, which is sort of the corollary to that, which is a unidirectional trace link over high-speed networks. So tomorrow's presentation will provide a lot more information on those 2 efforts, because I think it's something that interests a lot of people, and we've put a lot of work into that, and that's currently, basically this week, that's what we're going to be working on. In the short term future, we have a specification called the Trace Wrapper Protocol 1.1. This is just an update to the existing TWP specification that will add some enhancements to better map to what we're doing in gigabit traces. We'll just be explaining how to use the Trace Wrapper Protocol to interface with a generic high-speed network. And then there's a System Trace Protocol 2.1 update. There's one spec bug in that, unfortunately, that we need to fix. And so there will be some clarifications and small enhancements that we may add to that as well. Long term, I won't go into this a whole lot because this is obviously nowhere near committed. We're considering a sneak peek 1.1 update, and we need to expand our open system trace framework because we don't have enough in that right now. We're always looking for new interfaces for the narrow interface for debug and trace specifications. And also right now, you'll see we have a gigabit trace and sneak peek are focusing on USB, and we're considering other interfaces within the mobile space like Unipro. So real quick, this sort of gives you an overview of the architecture that we're working on, and I'm trying to show that we kind of work at all levels within the system. So, you know, at the lowest level, we specify board connectors. So technically, we recommend board connectors. I take that back. Please don't tell anybody that I said specify. So we play at the board pin level. And then moving into the chip, we have some of the other specifications. The PTI talks about the actual physical and electrical characteristics of trace. The MIPI NIDENT effort talks about how you can remap functional interfaces like the micro SD card interface and have debug functions remapped over that so that you can debug in a fluid system just by plugging a debugger into your micro SD connector. Gigabit trace and MIPI sneak peek are all about having high-speed networks interface with the on-chip debug technology that we have. And then we go a little bit deeper with things like the MIPI trace wrapper protocol and the MIPI system trace protocols. And these are very useful generic building blocks that allow people to build complex trace systems with a set of common primitives that can be used in all trace applications. And then finally we get to the software layer where we have the MIPI open system trace specification family. So as you see, it gets pretty complex, and hopefully tomorrow I'll be able to do a better job of explaining how all those pieces fit in. So to finish up, this is the list of active participants we have, and they come from many different facets of the industry. We have tool vendors like Lauterbach. We have OEMs. Most of the major silicon vendors that participate in MIPI actively are in the debug working group. I'm the chair. I work for Texas Instruments, and the vice chair is Jean-Francis Duray. He works for ST Micro. And we get some program support from the ISTO. We participate in all the quarterly face-to-faces. I guess those are not, I don't know what the word for tri-year or whatever, because we don't do quarterlies anymore. I guess that sort of carried over from previous presentations. And we have bi-weekly conference calls for a couple hours each time. And it's kind of interesting if anybody wants to participate, because we always, as you can see, we have several specifications at various stages of development at any given time. And I would encourage anybody that is a promoter member, or a contributor member, excuse me, to call in and find out what the latest thing is in debug and provide us your feedback. So, it's time for questions. But like I said, if you have any really interest in this, it might be good to show up at 4:15, right, tomorrow, Marcia?
Correct.
And I promise I won't try to go as fast as I just went through that. We'll drill down a little bit more on all the different specifications.